All right, ladies and gentlemen, welcome to my online lessons. Because of the coronavirus, we will have to close down the school for at least 2 weeks. So in the next few weeks, next week or so, I'm gonna be uploading some videos over here, and hopefully for every day you're gonna get a lesson with my voice recorded and with some notes taken over here, and that should be able to help you learn most of the key concepts for each day. Here's an overview of this whole unit over here. We have a lot of stuff to be covered. This is a big unit. We are going to start with similarity and congruence. Okay, we're going to start with congruence, and then we're going to move on to similarities. Okay, so hopefully by the end of next week, we will finish covering the congruence and similarities. And then past next week, if the school is still closed, we will be uploading some travel graphs, handouts, and we'll be moving on to that. So the first thing that we're going to start with is congruent triangles. We're going to start with the idea of congruence. What defines two figures to be congruent in this case? Pause the video if you need some time to think about it. Give yourself a few seconds. Okay, so in this case, you probably know in your head that in order for two things to be congruent, that basically means we have to have the same shape and same size. Okay. Now the question is, does orientation matter? It probably doesn't really matter in this question over here. So, for example, we will group B and E together. Okay, both of them having the same color, same size, same shape, and then you're gonna put A and B together. Sorry, A and D together. Okay, you probably notice that B and E, for example, they're not the same actually, because not only the direction actually doesn't really matter, but just the water drips over here. One is having it, the other one is missing. Okay, C, because the color is not the same with anyone else. Okay, so that gives you a brief idea over here. Now the next thing over here, this probably illustrates the real meaning of congruence over here. For example, if you're talking about A over here, A will be congruent with D and M in this case. Okay, why is that? Because A and D for sure they're the same, because they're same size and the same shape. Okay, and M the same size, same shape, and then different orientation. Guys, different orientation is fine. The orientation actually doesn't matter as long as you have the same size and you have same shape. Doesn't really matter how you rotate the picture over here. Will still be the same. Okay, so that's one thing that you probably need to keep in mind. Okay. The next thing that we're gonna get is C. How about that? C will be with O. Okay, how about E? E doesn't have anyone. F looks like it's similar with G. F and G are the same shape but different size, so we won't take care of that for now. Okay, and the next thing that we're gonna check is I. Okay, I and L are the same shape, same size, orientation doesn't matter over here. And I think that's pretty much it. Others are either totally totally different in terms of shape and size, and some are the same with shape but different size. Okay, we need to have same shape and same size in order to be congruent. So here's a key idea over here. When two triangles are exactly the same in shape and size, we say that they are congruent. So how do we make sure that two triangles are congruent? If they have all three angles being the same and all three sides being the same. Okay, so we need to actually check 6 different informations over here. We need to check 1, 2, 3, the 3 sides over here, make sure that they're the same. And then we also need to check 1, 2, 3 to make sure that they have the same angles. Okay, but do we need to always check through all 6 of them? That's a question. Let's say, for example, if you only have 3 pieces of information over here, if you only know 3 angles being the same, does that really guarantee congruent? In that case, as you can see from the diagram over here, it actually doesn't. Okay, because what you can do is you can always, drag the size as long as you guarantee the angles being the same. Okay, the shape is the same, but then the size cannot be controlled in this case. So in this case, we actually can't guarantee. Okay, we cannot guarantee congruence in this case. Okay, now the next question is, if you actually have 3 sides being equal, can we actually guarantee congruence? As you can see, in this case, if you actually have 2 triangles with all 3 side lengths being the same over here, let me get back to the original. Okay, as long as you have 3 sides being exactly the same, meaning that we have C exactly the same size as KC, A exactly the same size as KA, and B exactly the same length as KB over here. If you have all 3 side lengths being exactly the same, you will realize that automatically the angles are also the same. Okay, like that. So actually, here's a shortcut over here. That's a shortcut that we're going to talk about today. That if you actually have all 3 sides being equal, we're actually talking about this thing called SSS. Okay, so we have SSS, side congruence. That being said, what does that mean? That means if you have three sides being the same, that means you have also the 3 angles automatically being the same. So that means you don't actually have to check through all the 3 angles, because the equivalence of all the 3 sides will guarantee the equivalence of 3 angles. Okay, so the next thing we have SAS, AAS, and RHS. You guys probably heard about that already. One thing that I just want to tell you is this RHS, which is a little bit tricky over here. So R means a right angle, and then H means hypotenuse. Okay, so I need to have 2 triangles that are both right angle triangles with hypotenuse being the same and with another one side length being the same. Okay, like this. So as long as you can achieve that, we can also automatically guarantee congruence without actually having to check through all three angles and all three sides. Okay, you probably realize that we're missing one more thing over here. Yes, we have one more called ASA. Okay, it means angle, side angle. That's basically describing if we have two triangles with angles, angle, and the side right in between the two angles over here. That's what the order of the spelling suggests over here. Your S has to actually be right in between the two angles over here. Okay, so notice the difference between the ASA and then the AAS. Okay, they are kind of different things, but both of them actually guarantee congruence in this case. Okay, take a look. Now the next slide, we're going to talk about the two cases that don't actually guarantee congruence. Okay, for example, the first one, well, as the name suggests, we actually don't guarantee congruence. If you want to try to be a little bit appropriate, you can spell it as SSA in this case. Okay, but basically what it's suggesting is that if you're fixing an angle over here, okay, and then you're fixing a side line over here, and then you're fixing a side line over here, what you're gonna do is you are fixing these things over here, but the thing is you're actually not fixing this angle over here. So that allows you to actually dangle around, okay? So that your blue bar over here, for example, it can be dangling around, forming like different triangle as long as I, extend my line over here. This line over here also is not fixed, right? So you can actually make it longer or shorter over here. So that's why in this case we have two different triangles. The next case is AAA. We talked about that already. If you only have three angles being the same, you can actually, magnify it and minimize it to actually see, many different kinds of triangles over here. So in this case, we actually also don't guarantee congruent. Okay, one example over here. Are these triangles congruent? Give it a try. Give yourself a few seconds. Pause the video, and whenever you're ready, we can move on. Okay, so what's gonna happen is for each question, we're gonna point out yes or no. And if it's yes, then we give a reason over here. Okay, the first one is yes, because we have SSS. Okay, second one is yes, we actually have this thing called RHS. Okay, if you take a closer look over here, you have a right angle over here, and then you have the hypotenuse being the same as suggested by the little dash line over here. And then lastly, you have this side length being the same. Now you probably realize that it's actually not, quite corresponding over here. It doesn't really look like they're actually corresponding to each other over here. But if you actually, for example, if you actually reflect this thing through the mirror and then you kind of rotate it a little bit, you will probably be able to see this image over here, which will be actually exactly the same as ABC. Okay, after reflecting and rotating, you will have, for example, the angle L over here, and then you have M over here and you have K over here. So this is actually exactly the same size and shape compared to ABC. Okay, so that's a yes, RHS. C is also a yes because we have ASA. Okay, now D, you're probably going to say yes because AAS, but it turns out that it's actually a no. Why is that? Well, because if you take a look at that, you have two angles being the same over here. You actually also have another two angles being exactly the same. But what's happening over here is that the third side over here, even though they are the same, but they are corresponded to different angles over here. This AC over here is corresponding to the red angle. Now this XZ over here is corresponding to the Y angle over here. So they're actually not the same. We're not talking about the same size, the same corresponded size over here. So these two, despite the fact that they're the same, it actually does not tell us anything. So it's a no. Okay, so it's actually not AAS. If you want to have AAS, you actually need to say, for example, this side and this side needs to be the same. Okay, but it turns out that is not the case, so it's not. So that's it for today. Here's your homework. For every day, I will also post the homework page on the Power School Learning. You can see it in the video, or you can also check it on the Power School Learning platform as well. And that's it for today. I will see you in the next lesson. Peace.